Hello everyone, welcome to the next lecture on the GATE 2025 mathematics. Today I will explain you how you can solve the real analysis question. This is the part 1. I will upload the part 2 very soon. Till then you can simply follow my YouTube channel and you can see the various lectures related to the GATE 2025 mathematics available. You can see the complete playlist with the help of the shortcut tricks you can see in this at my YouTube channel. Also, you can see the playlist of the GATE 2025 mathematics where you can find the complete independent solutions of each problem. I hope you can subscribe my YouTube channel as well. Okay, the first question is related to the function is given and your target is to check whether the inverse function theorem is applicable or not. What is the shortcut tricks that I gave you? Whenever you have the inverse function theorem, you can find the Jacobian of the matrix. Fine. If it is non-zero, then you can say it is applicable, and whenever the Jacobian is my 0, then you can say the inverse function theorem is not applicable. Fine. So first of all, can you find the Jacobian? If I say this is my f1, this is my f2, partial derivative of f1 with respect to x, 3x square minus 3y square minus 3. Partial derivative of f1 with respect to y, minus 6xy. Partial derivative of f2 with respect to x and the partial derivative of f2 with respect to y. Fine. Now can you solve this? It will be 3x square minus 3y square minus 3 whole square plus 36x square y square. Is it fine? Then the first part is applicable, not applicable, not applicable, not applicable. Firstly, we will see the not applicable. When it will be the not applicable? If it is 0, when the Jacobian will be 0 because of this square value. That means each individual term must be 0. Fine, this will be 0 and 36x square y square must be 0. Fine. What is the meaning of that? That give you x square minus y square is equal to 1, and from this case x is 0, y is equal to 0. Clear? Now once x is 0 and y is 0, what is the value of the j? It is minus 3, 0, 0, minus 3. So the determinant is my non-zero. If it is a non-zero, then it is my applicable. But he said for all the point of the R2. If you look about this point, say 1, 0, fine. Then what is the value of the j? 3 minus 3, 0, 0, 0 and 0. So clearly say the determinant is 0, but he said for all the point is applicable. The first option is cancelled. Now because of this quadratic, I can also take it as a minus 1, 0. Fine. At the point 1, 0, Jacobian is 0. At the point minus 1, 0, Jacobian is also 0. So exactly one point is my cancel out. Fine. At the point 0, 0, Jacobian is my non-zero. So there are only 2 points. There are only 2 points where the Jacobian will be 0. So that means the C option is my right answer of this problem. So you can see it's a very simple way. Moreover, you can also see it's a quadratic equations, so which has maximum of that 2 points. Fine. So 3 point can never be possible because this equation is my symmetric. So it is always occurring in the even numbers. So that's why 3 point is cancelled. C is the only right answer of the problem. I hope you can like and comment on this video as well. I will upload the part 2 of the real analysis only if you like and comment on this video. Okay, look at the second question. That's very simple and I'm very sure that your reaction will be look like say this cute girl. The S1 said that firstly you can find the limit x approaches 0 and then limit y approaches 0. Fine. So can you find this limit? I think that's a very simple question. If you take y approaches 0, so this value will be 0. This number is my 1 plus x sine of 1 by x square. Now clearly say when you take x approaches 0, this value is my bounded function. Fine. And when you multiply this by x, it is a 0. Answer is 1. So yes, the limit S1 existence. So A option cancel out. Similarly, for the S2, you firstly take y approaches 0 and then take x approaches 0. Fine. Or you can see firstly take x approaches 0, then the value of x approaches 0, this value will be my -1 plus 0. Answer is -1. Yes, this limit is also existence. So the C option cancelled. S3, you taken both the limits at the same time. So when you take both the limits at the same time, I can choose the path y is equal to mx. Once you take y is equal to mx, your answer will be 1 minus m square over 1 plus m square plus x sine of x square plus m square into x square, provided limit x approaches 0. Again, you can see this is my bounded function, so that will goes to the 0 because of this x term. So the answer is 1 minus m square over 1 plus m square, which is not unique. Once this is not unique, that means the S3 does not exist. So the left option B is my right answer of the problem. Okay, look at this another one. Let A is the unit vector which is parallel to the tangent of the intersection of the surface, the absolute value of the directional derivative. This is the directional derivative. Find gradient into the unit vector. And if your reaction is look like say this off, believe me, you will see the solution and then your reaction will be changed to the wow. How? You can see. So how you can find the gradient of the f? F is given to you. So I can write the gradient firstly. What is a gradient? It's a 2x I cap 4y j cap minus 2 root 11 of k cap. Fine. So at the point P, P is given as a 1 root 2. So this value is 2 cap 4 j cap minus 2 root 11 k cap. How you can find the unit vector n? What is given to you? This is the intersection of the surface. So I consider this surface is my G1. This surface is my G2. So can you find the unit vector? Yes, it is a gradient divided by its unit vector. Fine. So can you find the del of G1 at the point P? So the del of G1 is 4x I cap 6y j cap minus 2z k cap. Gradient of the G2 is 2x I cap 2y j cap minus 2z k cap. So can you find the n cap? Or instead of the n cap, firstly, can you find the cross product? So it will be I j k. Find the gradient value at the point P. So it will be 4, 6 minus 2 root 2. Then 2, 2 minus 2 root 2. So can you find the answer? It says minus 12 plus 4 minus 8 root 2 I cap. Minus of j, it's a minus of 4 plus 4. It's a minus 8 minus minus plus root 2 j cap. 8 minus 12 minus 4 k cap. Fine. Divided by its magnitude. So that will be my n cap. So that is a 64 into 2, 16. Sorry, it will be minus 8 plus 4. It's a 4, sorry. So it will be 16 into 2 plus 16. Is it fine? So now you can find the dot product. Can you find the dot product of this? So it will be minus 16 root 2 plus 16 root 2 plus 8 root 11 divided by this value. It's a 128, it's a 32, it's a 16. Fine. So 6, 3, 6, 7, 176. So what is the right answer? So that will be, so I can write here, this will be 8 root 11. What is a 176? 4 root 11. So that will be 2 is the right answer of the problem. Fine. So it's a very simple. You can find a gradient and find the unit vector which is a parallel to the intersection of the surface. Don't forget to like and comment on this video. I will upload the part 2 of this real analysis if I feel you can give me a good likes and comment on the video. Find the volume of the solid reason by this. So from the case you can see I can find the value of the y is 4 minus x square. I can also find the value of the z is in terms of the x. Fine. Again you can see this is symmetric in x, y and z because of the even degree. So what is the volume? I can write this is 8 times dy, dz, dx. Fine. Otherwise, or you can write as a triple integration. The value of the z is minus 4 minus x square. This is the value of the dz. Then I can write as a dy. Again, it's a minus 4 minus x square. 4 minus x square. Then the value of the x will be minus 2 to plus 2. Now, because of the symmetric, I can write this term is 8 times triple integration from 0 to 2, 4 minus x square from 0 to 2, and 4 minus x square dz, dy, dx. So that will be 8, 0 to 2. If you integrate with respect to z, it will be root 4 minus x square. If you integrate with respect to y, again it is 4 minus x square. Fine. So now what is the integration of this? This value will be my 4 minus x square. If you integrate them, it's a 4x minus x cube by 3 from 0 to 2. Can you get the answer? It is 8 minus 8 over 3. So that will be 24 minus 8, 16. 8 into 16 divided by 3. So that will be 128 over 3 is the right answer of this problem. You can divide them to the decimal places. 42.66 is the right answer of the problem. Okay, look at this another one. What is given to you? The value of the f is given. N is the unit normal outward vector. Which things come in your mind when the unit outward normal vector given to you? That means you can apply the Stokes theorem. Fine. But because this is my curl of the f. Fine. And you all knows that divergence of the curl is my 0. That means the Stokes theorem is not applicable. Fine. For more details, you must see my this lecture, Gauss divergence theorems. Fine. That then you will analyze that how you can solve these integrations, how you can solve this part. So I can, instead of the Stokes theorems, you can apply the line integral I call as the f dot dr. Fine. Whenever the divergence of the curl is 0, Stokes theorem is not applicable. You can apply the line integral. So what is the dr? Dx I cap, dy j cap, dz k cap. So I can substitute the value. What is the f dot dr? F is my this case. You can take the dot product. It is y minus z of dx plus z minus x of dy plus x minus y of dz. Fine. Now given that it's the equation of the sphere, but the value of the z is lies between 1 to 4. Can you find the value of the z minus 1? This value will be lies here is 0 to 3, and you can see that the value of the 3 is my circle radius. So I can transform this equation is x square plus y square is 9 and z minus 1 will be 0. Fine. Now you can substitute this value. Once z minus 1 is 0, that means z is equal to 1, dz is my 0. So that value will be my 0. Fine. So it will be y minus 1 into dx plus 1 minus x into dy over the closed curve of the circle. Then how you can apply that? You can apply the green theorems. Fine, because it's a continuous functions, so you can apply the green theorem. Double integration derivative of this part with respect to x minus derivative of with respect to y into dx dy. So what is the answer? Minus 2 is outside. Double integration of dx into dy. So can you find the double integration of dx into dy? That's the area of the circle. What is the area of the circle? Pi into r square. So the answer is minus 18 into pi. So if you substitute the value 18 into pi here, pi will be cancelled. Minus absolute value is 18 is the right answer of the problem. Fine. For more detail about the line integral and the green theorem, you must watch about my this lecture, line integral and the green theorem. You will be enjoying self. You can see 24 years questions with the help of the shortcut tricks. I hope you can like and comment on the video as well. Okay, look at this another one. C is the point of the intersection of the surface z square, x square plus y square and 4x plus z is equal to 7. If your reaction toward this problem is very confusing in the examination, you can see I will tell you how you can solve this question in a very simple manner. What is the meaning of that? This is the equation of the in the xz plane. So what does the meaning of that? That means y will be 0. Fine. In the xz plane, and C is the point of the intersection of these two surfaces. When y is equal to 0, the value of the z will be plus minus x. So what are the points? Plus minus x, sorry, x will be my x, y will be 0, z will be plus minus x. Fine. This is the point C. C is the curve on the, this is the point P, any point P. If P is the point on the C, this is the point P, which is at the minimum distance from the xy plane, which is a minimum distance from the xy plane, then the distance of the point P from the origin. Minimum point on the xy plane. So on the xy plane, z will be 0. So once the z will be 0, can you find the value of the x? X will be 7 by 4. So this point will be my 7 by 4, 0 plus minus 7 by 4. Is it okay? 4x plus z is equal to 7. Okay. Firstly, you have to find this unknown point. Fine. Just wait. So on the point x is equal to plus minus z, I can substitute here. So this will be 4x. If I consider the first point is plus, then it will be x is 7 over 5. Or if you consider as a minus of x, then it's a minus of x, then x will be 7 over 3. Fine. So your points are 7 over 5, 0, fine, or 7 over 3, 0, 7 over 3. Fine, it's a plus minus. Is it okay? Now your target is to find the distance from the origin. If I say this is my A, so can you find the distance from the origin? That is x minus 0 plus y will be the 0, z minus 0. Fine. So I can take for the first case A, it will be 49 over 25 plus 49 over 25. So that will be 7 over 5 root 2. And for this case, it is 7 over 3 root 2, because your target is to find the minimum distance. Which one is the minimum? Either 7 over 3 root 2 or 7 over 5. So 7 over 5 root 2 is my minimum distance, is the right answer of this problem. It's a very simple. Your target is to find the xz plane. So y will be 0. Find the point of the intersection by substituting in this given equation. So you will get the point. Once you know the point, you will get the minimum distance. Okay, look at this another one. There are the two metric space are given. If the open ball centered at 0 is with radius 1 by 7 in the D1. This is my 1 over 7 in the D1 metric is equal to, these are the same as of the open sphere on the 0, 0 with the radius 1 over A in the D2. Fine. D1 is a distance. So I can consider y1 and y2 0. So this value will be my mod x1 plus mod x2. This is my radius 1/7. That is a distance d1. Fine. If you look about d2, again the center is distance from the 0 0. Fine. So this value will be my d1 over d1 plus 1, which is equal to 1 over a. Fine. Now d1 is my 1/7. So it is 8/7, which is 1 over a or alpha. Fine. This is alpha. So can you find the value of the alpha? So you can see 1 over 8 is 1 over alpha. Alpha is my 8 is the right answer of this problem. So you can see it's a very simple. It's a simple open ball whose radius is 1/7 in the D1 space, a metric. This is the D2 matrix. So the value of this metric is given as a 1/7 radius, and you can get the answer 8 is the right answer. Fine. I hope you can like and comment on this video as well. So I will upload the part 2 very soon if I get the good number of likes and comments on the video. Till then, you can share this video with your friends. Best of luck, students. Happy learning.